Hey Honors Chem Stars, this is Ms. McCauley bringing you Chapter 9 homework, page 2. Now I know that on the previous video, level 2 had a slightly different page for you. Good news is most of them were all the same. The only thing that was different were the acids. So I'll just go over those real quick to catch you up on those. So remember on all of our acid names, we have a little kind of like poem to memorize. Sprite is delicious. My ride has hydraulics. I ate something icky. So any acid or polyatomic, ite and us go together. Ide and hydroic acid go together, and ate and ick go together. So when we're looking at these acids over here, chloric, I ate something icky, comes from the chlorate polyatomic anion. So chlorate is ClO3 1-. The acid tells you it's H1+, the cation. We do a little simple crisscross, HClO3. Chlorus, Sprite is delicious. So chlorite, ClO2 1-, and the acid is H+. Crisscross those, you get HClO2. Now, you gotta be careful with number 16 and 17, perchloric. I ate something icky. So perchloric came from perchlorate, which is ClO4 1-. The acid is the H+. Crisscross, you get HClO4. And then hypochlorous. Sprite is delicious. So hypochlorous came from hypochlorite, which is ClO 1-. And then the acid is the H1+. Crisscross your charges, you get HClO. Okay, so if you need more help on the video, just watch the level 2 one, and here's the part you missed. Let's go to page 2. Okay, I'm going to put the screen shade here so we can kind of focus on a couple problems at a time. So let's look at the very first one on page 2. This is a combustion reaction where the reactants are C6H14 and O2 oxygen, and they're going to produce, like every combustion, CO2 and H2O. Remember when we're balancing these, balance C, then H, then O. So C, then H. Now we got to count up our oxygens. 6 times 2 is 12. 7 times 1 is 7. 12 plus 7 is 19. That means I've got to get 19 oxygen right here. So what can I put in front? 9.5. Now this is our little trick. We called it half balancing. So you half balance your oxygen, then double it to get a whole number ratio. So if we want to make this proper, we're going to make this 2. Double this, you'll get 19. Double this one, we're going to get 12, and then double this one, we're going to get 14. Now they're still in the same ratio to each other, but we've gotten rid of that half. So what's the ratio of C6H14 to O2? Before it was 1 to 9.5, but now that we've made it all whole numbers, it's 2 to 19. And if you divide that out in your calculator, you'll get those are actually the same ratios. And then what's the ratio of the hydrocarbon to the water vapor? That's going to be 2 to 14. So you see how they're the same ratio, but now we just have them in whole number terms. Okay, let's go down to the next part, a review from what you learned in the videos. Oops, struggling here with my touch screen. So remember, divide, oops, oh boy, having all kinds of struggles here. Let's highlight this. Remember, divide by what you have, multiply by what you want. The other way we can say that is what you have is the known and what you want is the unknown. So the way I like to think about this is what you have, it's the coefficient of the known. It's the ingredient from the problem. And we're going to multiply that coefficient by the mole ratio, which is unknown over known. And then that mole ratio is always going to come from the recipe, the balanced equation. Okay, take a second, if you need to pause it, kind of jot down these notes. I'm going to refer back to that when we go through all the problems. So let's focus on this one. We have the combustion of a hydrocarbon, the same problem from above. See, now it's balanced here for you. And this is the recipe. Now we've got how many? We got like what, 5, 6, 7 practice problems. So let's look at this first one. Number 1, they're saying you have 4 moles or 4 molecules of the hydrocarbon. How much will you need exactly of everything else? So we're going to use up exactly that 4, and then how much oxygen will we need? We'll need 4 times the ratio. The mole ratio will pull from that balanced equation from the recipe. So the ratio of that is going to be 19 over 2. The ratio for the carbon dioxide is going to be 12 over 2. The 2 comes right there. And then the water, 14. It's supposed to be a 14 over 2. Now, I've left it this way. Do you see how the black cancels out right here? So that's going to be the known canceling out with factor labeling. And that'll give us a final answer. So let's kind of try and do this in our head. 19 divided by 2 is, what's 19 divided by 2? Well, 18 divided by 2 is 9. 20 divided by 2 is 10. This must be about 9.5. What's 9.5 times 4? So 9.5 times 4, we're going to get 38. So we actually need 38 oxygen here. I I really wanted to show you the work, so I didn't just put the answer there and confuse you. How about the next one? 12 over 2 is 6. 6 times 4 is 20. Oh, oops. Wrong pen here. Wrong pen. Is 24. And then my last one for the water vapor, 14 over 2 is 7. 7 times 4 is 28. So we'll need 28 water. We'll get 24 carbon dioxide. We needed 38 oxygen, and that will be 4 here. Now, that was a lot of messing around with ratios. You might be like, oh, look, it's just a double batch. Double it, double it, double it, double it. Yeah, it checks out. But the reason we're going about it the long way is because as we go down through these problems, it's not going to be a simple double batch. Maybe it's going to be a 0.5 or a 3.7 or something like that. So let's just kind of take a scan through these and see how I have them set up. So I labeled the known, and I put that known coefficient, and then I've set up the bottom of the mole ratio. So there's my 19. So what's going to be my number on top here for the mole ratio? It's 2. The 2 came from right there. Here, it's going to be 12. And then over here, it's going to be 14. Now, what is 1 times 14 over 19? I don't know, and I don't really care. You can easily plug this into your calculator if you need to get the decimal number. I'm going to leave it as the fractions just because it doesn't give us a reason to go to the decimal numbers here. I want to make sure you understand where I'm pulling these fractions from. Okay, so now number 3, this time the known is the water vapor, so everything's going to have a 10 out in front, that ingredient 10 from the water vapor, and then it's going to be times the mole ratio. The known, see how it's in the denominator there? It's going to cancel out with the 10, and we've got to just pull our other coefficients from the mole ratio up here. Here it's going to be 12, here it's going to be 19, and then over here we're going to put 2. So what do you notice? In the columns going down, right, they all have the same numerator because they all have the same balanced chemical equation there. And then we're just changing the coefficient that's out front. Let's try a few more of these together. Okay, let's see here. Now we have, this is our known, the carbon dioxide. So it's going to be 0.5 times 2 over 12. It's going to be 0.5 times 19 over 12, and it's going to be 0.5 times 14 over 12. Okay, if you really want to know what the answers are, just take out your calculator and get a decimal equivalent for those. And then let's see, here we go. This time my known is the oxygen, so you can see I put that 3 out front, and oxygen's balance coefficient is 19. And then here we're going to put 2 in the numerator, the mole ratio of the unknown hydrocarbon to the known oxygen. So here it's going to be 12 for carbon dioxide, 12 over 19 times 3. And then over here it's going to be 14 for my oxygen. Okay, 2 more on this problem, then we got another one to go. Now here things start getting kind of icky. So here the known is 0.42. Now if you can do that in your head and be like, oh, I need to have so many times a batch to get there, go for it. Otherwise, we need to really start using these mole ratios. So if my known is 0.42, go back up to your balanced chemical equation. My coefficient for the hydrocarbon is 2. So how much hydrocarbon do I need? I need 0.42 times 2 over 14. For fun, why not? Let's figure out what that is as a decimal. So 0.42 times 2 divided... Oh, wait, did I do that right? Hold on. Clear. 0.42 times 2 divide by 14 is going to give us 0.06. So I need, this answer right here is 0.06. Now how about for my oxygen? Okay, 0.42 times 19 over 14. Let's give that one a whirl in the old calculator. 0.42 times 19 divide by 14, 0.57. 0.57. Okay, and now we've got our carbon dioxide coefficient is 12. So we're going to be taking 0.42 times 12 divide by 14, and we get 0.36. 0.36. So I hope that this example really shows you why we need to spend time understanding our mole ratios. Sometimes maybe I'll do a double batch or a quadruple batch, but sometimes we've got to go from 14 to 0.42. This is a much more realistic example of what we're going to be doing in this chapter. So this is going to be our realistic, oh, pretend this says realistic. I'm trying to write this out. Hold on, we'll fix it. So this is going to be a realistic example. right here. Okay, and we're almost done. We've got a little bit more left on this page. So here's a double replacement reaction. We have to balance it. I've gone ahead and done that for you. And just make a couple notes here. I like to put a box around that balanced chemical equation. It's the recipe. It's what we use to find those mole ratios. And remember, the mole ratio is the want over the have, also known as the unknown over the known. So if you haven't, just put, oops, I'm struggling with a smartboard again. You shouldn't be surprised by that. So I would just highlight this, write it on your paper. You don't want to forget this, okay? So the mole ratio is the want over the have, or the unknown over the known. So let's go in and fill in these last few blanks together. So on the first example, here's a list of the ingredients we have. Here's the recipe that's calling for the ratios. So if we know we have 4 of FeBr2, iron 2 bromide, how much of the H3PO4, the phosphoric acid, will we need? Okay, it's going to be 4 times the mole ratio of the unknown phosphoric acid, which is 2, to the known FeBr2, which is 3. You can go and plug this into your calculator if you want. I'm not going to bother with that right now. I care about having that fraction set up right. And let's see, the next one. The ratio is 1 to 3, 1 over 3 times 4, the 4 coming from right there. And let's look at our last one. Here it's going to be 6 over 3. Now, why am I not reducing this down to just 2? Because I want you to see where the numbers come from. I really want you to over-show your work on this rather than under-show your work. Okay. Next one. 2 more, then we're done with this video. Next one, our known is the phosphoric acid. Its coefficient is 2, so everything here has been set up with 0.15 times something over 2. Go back up to your balanced chemical equation. That's where the 2 came from. So for the iron 2 bromide, coefficient is going to be 3 over 2. For the iron 2 phosphate, we're going to put a 1. And then down here for the hydrobromic acid, we got a 6. Okay, well, let's look at the next problem. I still got the purple ink out. Well, that's going to be a 6 right there, too. So the known this time is the iron 2 phosphate, the 6.76 times the coefficients, the ratios here, 6 to 1. Over here, my ratio is going to be 2 over 1. And over here, my ratio is going to be 3 over 1. Okay, hopefully that helped you practice some more of the mole ratios. If you're confused, take your time, go back to the lecture videos, rewatch this video, and let your teacher know if you have any questions. Thanks, guys. I'll see you again soon.